A while ago, I was looking at a thermometer that was just lying around my house, and I realized that it has no ports that could connect to a computer. So I thought to myself, wouldn't it be cool if you had a system that could automatically read any meter without being connected to it? This gave me the idea for my project. I created a set of 3 autonomous computer programs using Java that monitors a live camera feed and can identify specific changes such as motion, color, and number values in real time. So my first program uses a camera to detect and respond to changes in color within a selected region of interest. So this is my main code. It was made using an integrated development environment, or IDE, called JGrasp. At the top here, you can see that I have imports, which is basically external data or libraries that we can use in our code. Over here, we can get the closest color name for each of our RGB values. Down here, we can force our system to load a certain library. We can capture a video using this and create our graphical user interface here. Here is the part of my code that will calculate the color difference. It uses Euclidean distance, which is basically a 3D plane of which the red, green, and blue values are contained. So here's my demo for the color detector. Over here I have a webcam that's just hooked up to my computer, as you can see there, and it's just on a stand, and it is pointing to this clear container of water. It's quite low. Over here we have green dyed water, and we'll be adding this to see the color change. You can see the program detecting the color change. Motion detection is widely used in fields such as security and automation, but in microscopy, it has a very different role. I developed a motion detection program designed specifically for the use with digital microscopes. Its goal is to track and identify movement in microscopic samples. Here is my code. I'll briefly explain the main points since it's similar to my color detector. Here, I set up the calibration for the video, which will be the reference frames. Over here, I created a foreground mask that highlights parts of the image that are different from the reference frames. Here, OpenCV finds outlines of areas where there's been movement. So here I have my program running, as you can see, and it's detecting movement. The main purpose of this detector was to show its uses in microscopy. So using a digital microscope that I have here, I have it hooked up to my program, focused on a small insect. My third and final program was to create an optical character recognition system that could detect changes in number values using any household meter. For example, pH, humidity, and multimeters could be read from the program. Here is my code. For this code, I used the IDE Eclipse because it was easier to import the data. I used the OCR and Tesseract external libraries to detect the numbers. So over here, this is the main line of code where the Tesseract will try to get the characters from the image. This was a live feed of the Microsoft stock price yesterday. Below the video is the result in confidence percent. Using any meter in your home, like this multimeter or this humidity meter, you could adjust the program to autonomously monitor the values for meters that can't directly connect to a computer. This program offers a simple and effective alternative. There are tons of applications for these programs. They can be used in home settings, microbiology, or just monitoring. One difficulty that I had was getting the programs to work properly under low light and low resolution settings. Thanks for watching.